Okay, hello Cloud Gurus and welcome to this lecture. Well, congratulations for making it to the end of this section of the course. So in this lecture, we're going to do our summary of what we've learnt about S3 and all my different exam tips. Okay, so let's start with the basics. So remember that S3 is object-based storage. It's a place where you store files. These can be PDF files, Word files, image files, video files, etc. It's not a place where you're going to install an operating system, or it's not a place where you're going to install and run a database from. For that, you need block-based storage, and that you would usually use EBS, which we're going to cover in the EC2 section of the course. Files can be anywhere from 0 bytes all the way up to 5 terabytes. And there's unlimited storage. Now, Amazon obviously monitor the storage capacity, and they add storage arrays as and when they reach certain thresholds. All your files are stored in buckets. What's a bucket? We should know by now, but obviously it's just like a folder if you think of it as a folder. And buckets have universal namespaces. So you see time and time again where I'm trying to register a bucket and people are trolling me by stealing my bucket names. So you remember that S3 is a universal namespace, and the names must be unique globally, and they must be all lowercase. And an S3 bucket name always looks like this. It's HTTPS or HTTP S3 hyphen then the region. So I'm in EU West 1 or EU West 2 amazonaws.com/a cloud guru. Okay, another really important thing to remember going into the exam is the consistency model for S3. So when you're putting a new object onto S3, you will get read after write consistency. So what that means is as soon as you put a new object on S3, you will be immediately able to read that object after you've written it to S3. How does that differ from this one? So eventual consistency for overwrite, puts, and deletes. Well, all that means is if you update an object on S3 or you try and delete an object from S3, those two actions can take a bit of time to propagate. So if you try and basically update an object and then immediately try to read from it, you might get the older version of the object. It won't propagate out to S3 instantaneously. So you get eventual consistency for overwrite, puts, and deletes, but you get read after write consistency for puts of new objects. So again, I'll just say that one last time so you understand. Any new object on S3, as soon as you put it onto S3, you'll be able to read it. But if you are going to update an object on S3, or you are going to try and delete an object on S3, if you immediately try to access that object, you may be accessing an older version or the undeleted version because it can take some time to propagate. So it's really important you understand that going into the exam, because they can throw those different sort of scenario questions at you. Also going into the exam, remember your S3 storage classes or tiers. So you've got S3, that's used for durable, immediately available, and then frequently accessed storage. You've got S3 infrequently accessed, so it's still as durable as S3. You can still have milliseconds latency in accessing objects on that storage class, but it's used for infrequently accessed objects. Remember, you are charged a fee for it. You've then got S3 reduced redundancy storage. This is known as RRS, and this only has a durability of 99.99%. It does not have 11 nines durability, so essentially the objects that you want to store on S3 RRS are objects that you can afford to lose. It shouldn't be mission critical data that's irreplaceable, and the example I like to use is things like thumbnails or watermarked images, etc. So you do have a lower cost than S3, but you have a lower durability as well. And then finally, Glacier. Glacier is the cheapest of all the storage classes or tiers, and it's great for archive data, but remember, you're always going to have a 3 to 5 hour wait when trying to access data on Glacier. The other thing you need to remember is just the core fundamentals of S3, and if you go to the practice exam questions on AWS's website, they'll talk about a key value store. So that is S3. So S3, you have a key. The key consists of the name of the object. The value is simply the data, which is in bytes, and then you have the version ID, you have metadata, which is data about data. The version ID, by the way, we did in the versioning section of the course where we had delete markers and all the different versions, etc. And then you have access control lists as well. The next thing you need to remember is that S3 is object-based storage only, so it's used for flat files. It's not suitable to install an operating system on or to run a database on, so you don't want to use S3 for that. What you would use for that would be elastic block storage, and we're going to explore that in a lot more detail in the next section of the course. S3 also allows you to do versioning, so you can store all versions of an object, including all writes, even if you delete an object. Remember with versioning, by the way, that you pay for each version of the object. So if you've got an object that's 1 gig in size and you then update it 10 times, you are going to pay for 10 gigs worth of storage. S3 versioning is a great backup tool, so when you go in and delete an object from S3, if you've got versioning turned on, it's just placing a delete marker over that object. It's not actually deleting the object itself, so do remember that. So once enabled, versioning cannot be disabled, it can only be suspended. The only way to completely remove versioning is to delete the bucket itself, recreate it, and then put your objects in there. Versioning integrates with lifecycle rules, as we saw in our lab, and versioning also allows you to do multi-factor authentication on the deletes. So essentially, if a user goes in and tries to delete an object, they have to authenticate using a multi-factor authentication token, so things like Google Authenticator or perhaps even a hardware token. So this gives you an additional layer of security. Finally, we also had cross-region replication that requires versioning to be enabled on the source bucket as well as the destination bucket. In terms of lifecycle management, it can be used in conjunction with versioning, or it can be completely independent of versioning. You get those different options as we saw in the lab. It can be applied to current versions and all previous versions, and the following actions can now be done. So you can transition to the standard infrequently accessed storage class. The rules for that, though, is that the objects have to be 128 kilobytes in size, as well as having 30 days after the creation date is when they can finally be transitioned to infrequently accessed storage. You can't do it any earlier as things stand today. You can also archive your objects off to Glacier storage. If you are using infrequently accessed storage, this is 30 days after you've moved that to infrequently accessed storage. So if you remember from the lab, the minimum value was 60 days from when the object was first created. Of course, if you're not doing that first step of moving things over to infrequently accessed storage, then you can move it to Glacier the day after that object has been uploaded to S3, and then you can also permanently delete objects using lifecycle management rules. Okay, moving on to CloudFront. So you just need to remember what an edge location is. An edge location is the location where content will be cached. This is separate to an AWS region or availability zone, and like I said earlier, there's at least 50 edge locations in the world currently. You need to remember the differences between an origin and a distribution. So an origin is simply the origin of all files that the CDN would distribute. This can either be an S3 bucket, an EC2 instance, an elastic load balancer, or Route 53. We then have a distribution, and essentially this is the name that's given to the content delivery network that will consist of a collection of edge locations. Remember, for your CloudFront distributions, you can have multiple origins, and so you're not restricted to just one origin. There's two types of distributions. There's a web distribution. This is typically used for websites, and then there's RTMP distributions. This is used for streaming essentially flash files. It's used for media streaming. And then our edge locations don't have to be read-only. You can write to them too, so you can put objects to them. This will put it to the edge location, and then it will automatically replicate up to the origin. Remember that objects are cached for the life of the TTL, and the TTL stands for time to live and is always in seconds. By default, your objects are cached for
24 hours when you set up that distribution, but you can actually change the default value. It's all configured when you go in and set up the distribution like we did in the labs. You can also clear cached objects from your edge locations, but you're going to be charged. Now, a use case for this is if you've updated something and you want to push it out to all your users, and let's say you don't want to have to wait for 24 hours for when the TTL expires. Essentially what you would do is you go in and you can clear cached objects on your distribution, but you are going to be charged for that. Okay, so moving on to securing our buckets. By default, all newly created buckets are private, including all objects within those buckets, and we saw that when we uploaded our logo and tried to access it, we got that access denied. The way we can make things public to our buckets is using two methods. So using bucket policies, which apply at a bucket level, or using access control lists, and these go all the way down to individual object levels. So we saw that when we made our logo object, we made that viewable by everyone in the lab. S3 buckets can be configured to create access logs, and this basically logs everything that happens to that S3 bucket when someone tries to access it. You can either log it to the bucket itself, or you can log it to another bucket within your account, and you can even log it to buckets within other AWS accounts, and we'll look at that a little bit later in the course. In terms of encryption, there's two types of encryption. There's in-transit and there's at-rest encryption. In-transit is achieved through SSL or TLS. So it's just basically, saying that you have to use HTTPS in order to connect into your buckets or CloudFront distributions.
And then there's 4 types of encryption at rest. So let's start with server-side encryption first. So there's server-side encryption using S3 managed keys. This is where each object is encrypted with a unique key employing strong multi-factor encryption. As an additional safeguard, it encrypts the key itself with a master key that regularly rotates. So this is AES, or Advanced Encryption Standard 256, and Amazon do all the management of that themselves. You then have AWS Key Management Service, or KMS, so server-side encryption KMS. This is very similar to the S3 encryption, but it has some additional benefits as well as costs. Essentially, there are separate permissions for the use of an envelope key, and an envelope key is just basically a key that protects your data's encryption key, and that provides additional protection against unauthorized access of objects within S3. The other cool thing about SSE KMS is that it allows you to have an audit trail of when your key was used and by whom. So it gives you a few extra options as opposed to S3, but again, that's something you need to remember going into the exam. And then finally, there is the server-side encryption with a customer provided key, and this is where you manage the encryption keys yourself, and Amazon S3 manages the actual encryption as it writes to disk, and then decryption when you try to read your objects. So really do remember those 3 points: SSE, S3, SSE KMS, and SSEC going into the exam. And then finally, you've got client-side encryption, and this is basically where you're encrypting your data yourself on the client side. You're then uploading it to S3, and it's dealt with as encrypted data. So moving on to storage gateway, remember the 4 different gateway types. So we've got our file gateway. This is for flat files only, and those files are stored directly on S3. We then had our volume gateways, which was broken up into 2 different gateways. The first one was our stored volumes. This is where your entire data set is stored on site and it's backed up to S3. Remember, with volume gateways, we're talking about iSCSI storage. So this is block-based storage. This is where you're going to have virtual machines, virtual hard disks, operating systems, databases, etc. So you either have stored volumes, which is where your entire data site is stored on site. This is great if you've got connectivity issues, maybe the connection is dropping out, or maybe you want really low latency. Those are the types of use cases you'd use for it. We then have cached volumes, and this is where the entire data set is stored on S3, and only the most frequently access data is cached on site. And then we have gateway virtual tape libraries, and this is used for backups basically popular backup applications like NetBackup, BackupExec, and Veeam use this as well. And then you basically take virtual backups of your servers and you store those virtual tapes off into to S3 and use lifecycle management rules to archive them off to Glacier. Moving on to Snowball, and remember I made the comment that you don't want to have a snowball fight with a friend when we're talking about AWS. They won't look as happy as this when you throw a massive 100 terabyte storage container at them. So what do you need to know about Snowball going into the exam? Well, remember the 3 different types of Snowball. We've got our standard Snowball, which is just pure storage. It can come in various different sizes. 50 terabytes was the starting size. That's still available in the US. Around the rest of the world right now, it's 80 terabytes. You would never be asked how big a Snowball appliance, how much storage a Snowball appliance can actually store. However, it's more important just to understand what it is at a high level. Snowball Edge has storage plus compute capability, so you can run Lambda functions from Snowball Edge, and basically it's like some mini version of an AWS data center in a box, and that's what they look like. They're quite heavy, they're quite large. You don't want to throw them at your friends, and then if you really don't like your friends, maybe you want to throw one of these at them. This is a Snowmobile. This is 100 petabytes worth of storage. It's on a 45-foot container driven by a semi-trailer. It can actually come with armed protection as well. Currently it's only available in the United States and only to some parts of the United States. People in Hawaii and Alaska are not yet able to get a Snowmobile, and the price is available upon application, and I've always wondered what the price is. So at a high level for Snowball, just to understand what a Snowball is, understand what import-export is, because they could still reference it, especially if a question is out of date, and a Snowball can basically import to S3, and you can also export from S3 to a Snowball. Moving on to S3 transfer acceleration. So you can speed up transfers to S3 using S3 transfer acceleration. It costs extra and has the greatest impact on people who are in a faraway location. And essentially what those people are doing is they are uploading files to an edge location, which is then being written to your S3 bucket. Moving on to S3 static websites. So you can use S3 to host static websites. It is serverless. You don't have to worry about EC2 instances or virtual machines. It's very, very cheap and it scales automatically. The only thing you need to bear in mind though is it is static only. You cannot host dynamic sites. You cannot have PHP or .NET sites running on S3. It's basically HTML and any kind of static content only. My last few exam tips: when you write to S3 successfully, you get a HTTP 200 success code. That's for a successful write. You can load files to S3 much faster by enabling multi-part upload, so it breaks the big files up into multiple pieces and then basically uploads those pieces to S3 and then puts it all back together again. And then my final tip is make sure you read the S3 FAQ before taking the exam, because S3 is going to come up a lot in the exam. So that's it for this section of the course, guys. Go have a break, go do something else, and when you're ready, come back for the next section of the course. Thanks a lot.